Hi, this is Chakib Madcur, and this is my final project for Calculus 1. In this project, I wanted to mix some of the topics that I have found the most interesting in this class with something that I am also passionate about, such as sports. That is why I have decided to choose a tennis problem and relate it with some of the topics that I have learned throughout the semester in this class. I believe that choosing a problem that involves distance and area, derivatives, slopes, maximums and minimums, Riemann sum could be a good possibility for me to show the skills I've learned throughout the semester. My problem consists of finding the distance that a professional tennis player forehand covers in the lapse of 10 seconds. For this, I'll be finding the distance of the problem using the Riemann sum, and then also I asked to find derivatives, slopes, maximums, and some other topics, which I'll be showing now. For this project, I also provided my audience with this table. For this problem, I used the Riemann sum, which was introduced by the professor a couple of weeks ago. The Riemann sum is a method to approximate the area under a curve by dividing the area into smaller rectangles and summing up their areas. I also displayed the information in a graph to demonstrate my understanding of the subject. Then I requested to find the slope at t equals 3 and t equals 7 to determine the rate of change of the distance covered by the tennis player forehand. This information can certainly be used to analyze the player performance and make necessary adjustments to improve his game. I also asked if there was any maximum value, and in case it was, at what t value and what the maximum value was. The good thing about these problems is that they can be applied to many other sports such as running, swimming, and cycling. I believe that choosing this problem made me display a good understanding of the subjects and also allowed me to show that I can connect these topics. Distance problems have application in this type of exercises where we need to find the distance covered by a certain object at a given time. Using the Riemann sum is a great approach for this type of problem because it gives you a very exact result of your problem. In the Riemann sum, what we have to do is use these numbers and then rest the numbers between. So, for example, I have 18 and 2 minus 0 is 2. Then I do the same, 26, 3 minus 2 is 1. That's why I have a 1 here. Then 37 and 5 minus 3 is 2. That is why I have a 2. And then you keep doing the same with all the other numbers. Well, since you have a 0 here, you would have to do the exact same thing, but since 0 multiplied by any number is 0, the result is not affected. That is why it's not shown. After solving this problem, we can see that Stefanos Tsitsipas' forehand traveled 478 meters from seconds 0 to 10. As we wanted to find the distance covered by Stefanos Tsitsipas' forehand, I used a derivative to find the instantaneous rate of change of his ball. The result of his slope gives us a distance function, which tells me how fast his forehand is going at any given moment. At t equals 3, the ball was going at 6.3 meters per second, and at t equals 7, the ball was going at 8.6 meters per second. For this, we just have to subtract the two numbers that are between t equals 3, which are 5 minus 2, and then in the numerator we have 37 minus 18, which gives us 19 divided by 3, which is 6.3. And in case of 7, we do pretty much the same. We use the two numbers that are between the number, which were in the numerator 80 minus 37, and the denominator 10 minus 5, which gives us 43 divided by 5, which is 8.6. To find the maximum value, which was my last question, we have to do pretty much the same. So at t equals 10, the maximum value is 80. Finding a maximum value at t equals 10, which our case is 80, means identifying the highest point of the function within a given range of values. The topics that I worked with, such as area, distance, derivatives, slopes, are subjects that are used in many real-life problems, such as engineering or physics, for example. In my opinion, choosing a problem like this, which relates all the topics that I have already mentioned, which are subjects that we have seen throughout the semester, was a big challenge for me, but it was very fun to work on, and it was a good opportunity for me to display all the things that I have learned throughout the course. So yeah, it was super fun, and thank you so much for watching.